Hi guys, hope you're having a good day. Today we are going to graph radical functions, and we're going to look at different roots of functions. So I want to start with one of the parent functions we've already talked about, which is the quadratic function, f of x equals x squared. And I want to consider the graph of that function. It's a parabola that opens up. And I went ahead and gave a table of values. What I'd like to do is find the inverse function of y equals x squared. All right, so I'm going to write that down. Y equals x squared. Well, we learned in a previous video that to find the inverse, it's a reflection over that line y equals x, which means I'm going to switch my x and my y values. And then I'm going to solve for y. So y would be the square root of x, and since I took the square root here of y squared, I need my plus or minus. So the inverse is plus or minus square root of x. All right, so what are some coordinates that go with that? Well, we also learned if I've got a table of values, then my x's and y's switch places. So I'm going to get this table of values. Well, if I graph that, 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2. So my reflection over that line, y equals x, is going to give me an inverse that is going to end up failing the vertical line test. So here's what I know, that the f of x equals x squared, well, that's a function. It passes vertical line test. However, the inverse is not a function. So in order to get, to make both of these a function, I need to restrict the domain. Okay, let me show you what that means. So if I restrict the domain of f so that the inverse of that restricted function is also a function. So that means I need to focus on where my x value is greater than or equal to 0. Okay, so let me write down the restricted domain. So if I restrict this domain to 0 to infinity, then if I reflect that part that is green over that line y equals x, then I get this part of the function. That's the part that would be reflected. Okay. So when we restrict the domain of f, now the part of the inverse that is highlighted in green there, well, that part, just that part, the top part of the inverse, passes a vertical line test. So with a restricted domain, we have a new parent function. Okay, and that's going to be the square root of x. So this inverse is going to be the square root of x. Okay, because the square root of x passes the vertical line test when we restrict that domain of our quadratic. All right, so let's take a look at our parent function. We have a new parent function. It's the square root of x. Now notice I gave you a table of values. 0, 0. I plug in x equals 0. The square root of 0 is 0. I plugged in 1. The square root of 1 is 1. Notice I picked 4. Well, why did I pick 4? Because when I take the square root of 4, I get that whole number. Went ahead and graphed it there on that coordinate plane. And the domain for this parent function, well, as I look at the x values from -infinity to infinity, the x values start at 0 and go to infinity. And the range, the y values, start at 0 and go to infinity. So notice this is the square root function, new parent function. Okay, this is going to be the family of square root functions that we are going to talk about. So this family of square root functions also has transformations that go along with it. Now, these transformations should look very familiar, except this is for the parent function, y equals the square root of x. Okay, so for our square root function. So the a, well, let's start with order of operations, x minus h. Well, this h, well, darn, let me rewrite real quick. Erased a little too much. Picked the wrong color, green. Erased a little too much. Let's try again. There we go. All right, so let me get a different color. All right, so this x minus h would indicate that you are having a transformation going right h. You're taking the parent function and moving it right h. If it's an x plus h, you're moving it left h. The a, if a is greater than 1, that's going to be a vertical stretch. If a is less than 1 but bigger than 0, that's going to be a vertical compression or a vertical shrink, however you want to say it. Okay. And then if I have a negative, I'll kind of put it up here in parentheses. This negative indicates a reflection over the x-axis. Now, plus k. If it is a plus k, that means I'm going up k. If it's a minus k, I'm going down k. Well, these transformations should sound very familiar to you because they're the same transformations that we have used for all of our other parent functions. Notice the location of the a, the h, and the k. Same transformations, same location. Okay? So, we can apply this to any power function. If I have y equals x to the n, say n is cubed, like a cubic, a quartic, a quintic function, then the parent function for that inverse with the restricted domain is y equals the nth root of x. And this is for all families of radical functions. Notice the transformations. F of x would equal a nth root x minus h plus k. Keep in mind n represents the degree of your function. It could be cubic, it could be quartic, quintic, whatever. Now, what are the transformations? Well, let's see here. X minus h means I'm going right h. X plus h, I'm going left h. Should sound familiar to you. The a value, if a is greater than 1, then it's going to be a vertical stretch. If a is less than 1 but bigger than 0, it's a vertical compression. Or you can say a vertical shrink. If I have a negative 1 or a negative out in front here, let me rewrite that. If I have a negative out in front, that negative indicates a reflection over the x-axis. Now, if I have a plus k, well, I'm going up k. A minus k, I'm going down k. So, and I'm doing the transformations based on whatever that parent function is. So if I had a y equals x to the third, then y equals cubed root of x is that inverse. Okay, so we can apply this to any power function that has a degree of n. So let's do a little practice here. Okay, let's graph each function. Well, first of all, I'm going to graph the parent function. Well, what is the parent function for each of these? Well, parent function, y equals square root of x. When I have f of x equals square root of x plus 2, that plus 2 indicates I'm moving up 2. So if I draw that parent function, 0, 0, 1, 1, 4, 2, and let me pick a different color here. Let's just go blue. We'll do this one in blue. And I move this up 2. Well, that would indicate from my table of values, 0, 0, 1, 1, 4, 2, that if I'm moving up 2, that means I'm adding 2 to the y value. So 2, that'd be a 3, that would be a 4. That means this 0, 0 would go up to 0, 2. This 1, 1 would go to 1, 3. this 4, 2 would go to 4, 4. That is the new function. All right, let me grab another color. Let's go purple. I'll do this one in purple. Okay. Well, what's the parent function? The parent function, well, y equals square root of x. What's the transformation? It's moving down 3. That means if I start with this red parent function and I move each point down 3, if I'm looking at that table, start with 0, 0, 1, 1, and 4, 2, I'm going to subtract 3 to the y values. That'd be negative 3. That's going to be what? 1 minus 3, negative 2, and 2 minus 3 is negative 1. So that means I'm going to move 0, 0 down 3, I get 0, negative 3. Move 1, 1 down 3, I get 1, negative 2. Move 4, 2 down 3, I get 4, negative 1. So those are our shifts up and down. Okay. Let's take a look at this guy. Again, let me go ahead and draw that parent function. 0, 0, 1, 1, 4, 2. Okay. And I will graph, get another color here. I'll graph this first one in blue. Well, the parent function, well, that's y equals square root of x. Notice that plus 2 is underneath the radical. If it's a plus 2, that's my h is negative 2. That means I'm going left 2. So that means with my table of values, 0, 0, 1, 1, 4, 2, I'm going to subtract 2 to the x values. And that means I'm going to move 0, 0, left 2. I'm going to move 1, 1, left 2. And I'm going to move 4, 2, left 2. And notice it matches up with my table. On this right-hand side, let me grab another color. I'll go with green. Parent function. Well, that is y equals the square root of x. Since that minus 3 is inside that radical, that means I'm going to be shifting right 3. So if I take that table of values and I use my parent function 0, 0, 1, 1, 4, 2, and I'm moving right 3, that means I'm going to add 3 to the x values. So that's a 3, 4, and a 7. So if I take the red graph and I move it right 3, I get 3, 0. If I move 1, 1, right 3, I get 4, 1. If I move 4, 2, right 3, I get 7, 2. And there is my new graph. Okay. So let's put, all of this together here. All right, so let's take a look at f of x equals negative 2, square root of x plus 2 minus 4. So notice we got lots of transformations here. All right, I'm going to start with my parent function. That parent function, y equals square root of x. That is the most simplest function. I'm going to use my points, 0, 0, 1, 1, 4, 2. I'm going to go ahead and graph that just so you will be able to see what this transformation looks like compared to that parent function. All right, so what do I know? Transformations. Well, this one's going left 2. It has a vertical stretch of 2. It is reflected over the x-axis, and it's shifting down 4. Okay, so I'm going to take each point and do that transformation. So if I go left 2, that means I'm going to subtract 2 to the x value. I get negative 2, negative 1, 2. A vertical stretch of 2, that means the y values are being pulled away from the x-axis. Multiply the y values by 2. 0, 2, and 4. Reflect over the x-axis. That's where you're multiplying here by the negative. That's 0, negative 2, negative 4. And then I'm going down 4. I'm subtracting 4 to the y values. Negative 4, negative 6, negative 8. That means I'm plotting negative 2. Let me grab a different color here. We'll go with blue. Negative 2, negative 4. So I'll mark that. Negative 2, negative 4. All right. Negative 1, negative 6. 2, negative 8. Notice, there's my graph. Okay. So that is taking the parent function, moving it left 2, doing a vertical stretch of 2, and reflecting it over the x-axis and then moving it down 4. Okay, I get the blue graph. Let's take a look at a higher degree power function. Okay, let me grab some fuchsia here. Parent function. Let's say we have y equals x to the third. Well, if I put in -2, -2 to the third, -8. -1 to the third, -1. 0 to the third, 0. 1 to the third, 1. 2 to the third, 8. Plot that. -2, -8. -1, -1. 0, 0. 1, 1. 2, 8. All right, so I'll do my best to draw. That is y equals x to the third. That's a parent function. We learned that the inverse is going to be the cubed root of x. Well, how do I get the coordinates for that? Well, remember, if we find the inverse, we reflect it over that line, y equals x, which means the x and the y values switch places. So I'm going to have, maybe I should do this in a different color. Let's do blue. -8, -2. -1, -1. 0, 0. 1, 1. 8, 2. Let's plot that. -8, -2. -1, -1. 0, 0. 1, 1. 8, 2. And let's graph it. That is the cubed root of x, which is also going to be another parent function. Okay. So let's apply that with the transformations. Notice h of x equals 2. Actually, I'm going to go blue. 2 cubed root x minus 2 plus 3. All right, what's the parent function? The parent function, y equals cubed root of x. That's the most simplest. So let's slide back up here. Notice cubed root of x, -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Let me write that down. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. That is our parent function. Now, we're going to work with this transformation. All right, so let me go ahead and I'm going to draw this parent function. That way you can see the transformation when we're all said and done. All right. There's the parent function. All right, I'm going to go back to fuchsia to graph h of x. All right, well, here's what I know. I'm going to use this table. What are the transformations? Well, I'm taking that parent function and I'm going to move it right 2. I'm going to do a vertical stretch of 2. And then I'm going to go up 3. So let's get those coordinates. If we're going to move it right 2, that means I'm going to add 2 to the x values. -6, this becomes a 1, a 2, a 3, and a 10. Okay. That takes care of the right 2. A vertical stretch of 2, that means the y values are going to be multiplied by 2. -4, -2, 0, 2, and 4. That means they're being pulled away from the x-axis. Now I'm going to go up 3. I'm going to add 3 to the y values. -4 plus 3, -1. -2 plus 3, 1. 0 plus 3, 3. 2 plus 3, 5. 4 plus 3, 7. Gives me my new coordinates. So plot -6, -1. Plot 1, 1. Plot 2, 3. 3, 5. And then 10, it's going to be off a little bit, but I'm plotting it anyway. 7. Notice the similar shape. That is moving it and shifting it right 2, stretching it and shifting it up 3. Now I want you to be able to take any equation and be able to rewrite it in order to find the transformations. Okay, so what you typically need to do is take a look inside here, that 8x plus 3. Now, can I factor that? That's the question. Well, let's see. R of x equals cubed root 8x plus 32, what do they have in common? They've got an 8 in common. That becomes x plus 4. Now, 8 here is a perfect cube. When you take the perfect cube, it goes to the outside. Okay? So, 8, cubed root of 8, well, that is 2. So that's going to be 2 cubed root x plus 4 minus 2. Okay, so that is my r of x. 2 cubed root x plus 4 minus 2. Now it says to describe the graph. Well, first of all, what's the parent function? Most simplest form. Well, y equals cubed root of x. What's the transformations? Well, if the plus 4 tells me I'm going left 4. The 2 out in front, well, that's a vertical stretch of 2, meaning the y values will be pulled away from the x-axis. And then minus 2 means we're going down 2. That's how you're going to describe the graph based on the parent function. You're just going to tell me what the transformations are. So take a look at p of x. Notice it is a square root of 4x minus 12. Okay, so p of x equals. Look at this 4x minus 12. What do they have in common? Well, it's got a 4 in common. And that would be an x minus 3 in parentheses. Well, this square root of 4 is 2. That 2 is going to go on the outside of that radical. And then I have x minus 3. So, how do you describe the graph? Well, let's see. Parent function, square root of x. What are the transformations? That minus 3 indicates we're going right 3. And then the 2 out in front means I'm having a vertical stretch of 2, meaning the y values of my graph are going to be pulled away from the x-axis. All right, hope that helps, guys.